If we want to determine the derivative for a trig function, like sine or cosine, maybe tangent, we would have to go back to the limit definition of a derivative because we don't have any shortcut rules for trig functions yet. Using that difference quotient and allowing the limit of h to go to 0 for the function sine x, we can hope that maybe a shortcut will come out of this. First, we're going to need to use a trig identity to replace the sine of x plus h term in our difference quotient. Remember that sine takes in an angle, and it's trapped inside of the trig function, so I can't separate that x and that h inside of the sine function without using an identity like the one we see on the screen, the sine of the sum of two angles. Applying this trig identity allows us to isolate the x's and the h's inside of their own factors. So we no longer have a trig function with x and h inside of it at the same time, but we will have sine of x times cosine of h, and cosine of x times sine of h. And hopefully that will help us out a little bit. We're going to regroup our terms, basically just reordering the terms in the numerator, and then that'll allow us to notice that we can split this into two fractions. In that first fraction, we have a common factor of sine x. If we factor that out, we're left with sine x times cosine h minus 1 divided by h. And then the other term, the other fraction there, cosine x times sine h over h. We can apply our limit laws, allowing us to distribute that limit operator to each factor and each term. And then we're going to evaluate our limits. That first limit, as h is going to 0 for sine of x, well, sine x doesn't depend on h, so that limit is just sine x. The second limit, cosine h minus 1, all divided by h, where h is approaching 0, we actually had to do a lot of work to find this limit, but if you recall, the graph of the function passes through the origin, which means the limit as h is going to 0 is 0. We have one more limit to evaluate, but before we evaluate it, let's notice that cosine x does not depend on h, so we can factor that out just like a constant. And then we're left with a familiar limit, the limit of sine h divided by h when h goes to 0. We used the squeeze theorem to prove that this limit is equal to 1. So now we can evaluate these products and sums. We have sine x times 0 plus cosine x times 1. That simplifies to just be cosine x. So for a function sine x, the derivative is cosine x. Cosine x is the derivative function for sine x. And we could use this same technique to show that negative sine x is the derivative function for cosine x. And with these two rules, we'll be able to include some of our trig functions in our product rules, quotient rules, and so on.